So you're going to want to have the unit circle off to the side when you do this. I'm drawing it right here because if you're watching the recording, you can't see what I wrote on the board. If you're physically here in the room, I have it right there so that you can look up to it. Because otherwise you would have to write it at the top of every single paper you would be writing on. So I'm just going to leave it up there so you can refer back to it. Okay, because I think you guys know that at this point, the zeros and ones moving. All of these say sine. So basically we're going to just go around the unit circle and pull all of the y values. Sine is the y value. So what'd you put for the first one? 0, good. And then at pi over 2 up here, what's our y value? 1. And then at pi, we're back to 0. And then at 3 pi over 2, -1. Be good if I put the negative there. And then the whole way around, 2 pi puts you back where you started at 0. Now we're going to go around backwards. You all buckled in? All right, if you go to negative pi over 2, that's going to give you -1. Negative pi is the same place as positive pi. That's going to be 0. Negative 3 pi over 2 will put you up here. That's +1. And negative 2 pi, again, it's the whole way around, puts you back where you started at 0. Isn't that fun? Ones and zeros and negative ones. Now we're going to plot them. So on your grid right here, you're going to start with the point 0, 0. So you're starting at the origin. And then at pi over 2, you're going to be at 1. And then back to 0, and down to -1, and then back to 0. I don't know if you remember because it was a really long time ago, but in unit 1, back in September, when we did all the parent functions and I had you matching them up, remember quadratic, cubic, exponential, all that, and you just had to match them up. I threw sine and cosine on there because I knew we'd eventually get to this date. Do you guys remember this at all with the little waves? Okay, I see some heads on. Perfect. This is what's called one period of the function. It's the distance it takes to complete one full cycle to get back where you started. But you can keep going. You can extend this forever. I'm just going to draw it until I've, filled the grid that I've got here. And do you guys, like, it's either physics or chemistry where you do like the sound waves. I think that's physics, right? Do you guys know what I'm talking about where you see these? Okay, so you've seen it. Perfect. It's the exact same thing, all right? And I like talking about these. I just go like this one. So that's your sine graph. So I'm going to highlight one period of the function. It's the distance it takes for you to do one full cycle and get back to where you started. So yeah, if you want to just grab a different colored pen or highlighter or something, highlight them. We'll highlight some other stuff today too. If you want to. You obviously don't have to. Your notes are yours. I'm just going to draw your attention to some things about the graph, because it's been a while since we've talked about graph characteristics. First, let's talk about the domain. This graph will go left and right forever. So what's its domain? Yeah, everything, right? All reals. By the way, please don't put arrows on the end of these. And this is why. If I stuck an arrow on this, what does that arrow mean? That it's going down forever. Is it going to do that? No, it's going to keep waving forever. So please just don't put arrows on. Other thing is, I'm not here to grade your art skills, but try to make it a nice smooth curve. Like, don't make it like a jack-o'-lantern mouse. Do you know what I'm saying? Like, it shouldn't be spiky. Like, make an attempt. Right? So domain is everything. Range is not everything. What are we stuck in between? -1, +1, brackets or parentheses? Brackets, good. There's actually points there. You only use parentheses if you have like an asymptote, like it's never going to touch. But -1 to 1, we're including those. Also, the graph is continuous, which means there's no holes or breaks or gaps or asymptotes. I'm bringing that up because next time we're going to do secant and cosecant. Those ones aren't continuous. You're going to get a little intro paper on all 6 of the trig functions like this. When you go to study them, you can go back and look at. I'm also going to bring up whether the function is even or odd. Sine is an odd function. We did even and odd functions again back. It was either unit 1 or unit 2. I know, like a million years ago. So I'm just going to review with you what that means. Odd means that it is symmetric to the origin. The reason I'm bringing this up now is which functions are even and which functions are odd will play a role in some of the stuff that we're going to do later this year. And again, I'm going to give you an intro worksheet on all of them, and you can have all that stuff written down. So sine is odd. Do you see how we have the origin here? This piece would be symmetric down here with this piece, like across the origin. Thank you. That's what it is, all right? I also like to bring up the Y-intercept because that's really the only difference. Like the easiest way you can tell the difference between sine and cosine is where they start. What's our Y-intercept for sine? 0, 0. This one starts at the origin because when we flip this over, cosine looks identical. It's just you can tell the difference by where it starts. So that's an important thing to think about. And then I just want to write out what is the period of the function. I highlighted it blue. It goes from 0 to where? 2 pi is the period. Why does it make sense that it's 2 pi? Because that should like make sense. One way around the circle. Very good. Okay, we're going to flip it over and do the exact same thing with cosine. Only difference is when we go around the circle, what parts of the coordinates are we going to pull? X, that's it. Other than that is the exact same thing, all right? So where do we start at for this one? What's our X value to start with? 1. Now you're up at the top of the circle. What's the X value? 0, and then -1, 0, 1. My hope is once we do enough of these, once you get the pattern started, you'll just be able to continue it because they're waves, it's cyclic. Now we're going to go backwards. Now you're at the bottom of the unit circle. X value is 0, -1, 0, +1. Perfect. If you just pay attention, they're really not too hard. It's all zeros and 1. Again, the reason we're not using, you're probably like, well, what happened to pi over 6, pi over 4, and pi over 3? Those points exist. It's just they're really awkward and weird. I don't want to graph square root of 2 over 2. So that's why we don't use those ones. All right, so plotting them, the only difference is this one's going to start at 0, 1. So you're going to start here and then do the wave. So this is one cycle of cosine. It looks like that. It's, again, the period is how long it takes to get back where you started, like to do one full cycle. So that's one period of cosine. Again, you can fill it in for the entire rest of the grid, though. It's going to keep doing the same pattern forever. And again, not grading your art skills, but like make an attempt to make it a nice smooth curve. Just it shouldn't have like pointy edges on it. You will see mine does not look real great. It's a little bit wonky, but just, make an attempt. So again, if you want to highlight it, you don't have to, but I'm just going to show you. This is one period of cosine. And I want us to write out the same stuff here that we did for sine. Because again, today we're doing sine and cosine, but there's 6 of these, and I'm going to give you a sheet like this for all 6 of them, and then you can use it to study. You'll have all of it like on one sheet. So what is our domain for cosine? Everything, all reals. Again, it goes both ways forever. Don't stick arrows on the ends because it's not going to go one direction forever, bless you, but it's going to keep on waving forever. Range, again, -1 to 1, brackets because there's actually points there. And the graph is continuous. And again, the reason I'm bringing that up is when we do some of the other ones, they aren't continuous, and it's just a compare and contrast kind of thing. Cosine is an even function, which means it is symmetric to the y-axis. Again, we covered that, but it was like back in September, October. So like, if it even rings a bell, I'm happy. And again, the reason I'm bringing that up now is it's going to be important in a unit later on. So that's like why I'm bringing it up now. But look, do you see how if I like draw a line at the y-axis, this would reflect over there? Like, do you see it, the symmetry? All I'm trying to get across there. And then where does this one start? What's the y-intercept? 0, 1. There we go. And again, I'm just bringing that up because otherwise it looks exactly like sine, doesn't it? And people are always like, well, how do I tell the difference? And if you look for where it starts, then that helps. And again, what would be the period, which I highlighted here? 2 pi. It's once around the unit circle.